come in at the beginning of class today, so I don't know if we'll get interrupted here briefly, but they're not here. So they were here earlier. Okay. So maybe they'll come back or we'll see. So for those of you, I think there's like 5 based on what it looks like on my end, who aren't seeing kind of your iClicker scores sync up. So I've got them sitting there under your physical iClicker remote. I put up an announcement this morning just to one last kind of try to troubleshoot. So you need to make sure 3 things are going on, and then we'll get to him. So the first, I just wanted you to make sure that you're enrolled under this course. I don't think that's the issue for most of you, at least what it looks like on my end. But this link kind of gives you, sends you right to where you enroll underneath your iClicker account. The second one is kind of if you already have an account where you can log in, and then make sure following these steps that you're getting your remote registered underneath that profile correctly. And then the third thing I think most of you have done correctly, at least what looks like mine, is get registered under a Canvas. So try kind of make sure you're enrolled in the course, make sure you've got it registered in these 2 locations. If that doesn't work, a couple you've already reached out to me. You've sent me what your actual physical iClicker kind of number is. I can manually update them on Canvas so it doesn't look like you're having zeros. Okay. So with that being said, I'll hand it off to you guys. And if I'm in your way, I was going to say, I don't know if you want to use this computer or the other one.
Whatever goes on the screen.
Here.
Are we in what class?
This is 221.
221.
Yeah.
What is 221? Stats.
Stats, business stats.
Your Dr. Green? Yes, I did. He passed away. He passed away.
He didn't pass away.
He's still going.
No.
Who did?
Business. I don't think anyone for business stats did.
Green passed away.
No. I've seen him. He comes in every a couple months. They still give him a cost. Yes, Dr. Spector. Yeah, he's that guy. All right.
You're like, I've seen him.
No, I've seen him. He's still going.
It's really awkward. Well, I'm Jonathan Lamb. This is Michael Roberts. So we are part of the advisory board here for the Department of Economics. And so make no qualms about it. What we're here to do is to recruit you, because I know you guys all love 221. This is the greatest thing ever. But so each university within the university has an advisory board. We're part of the advisory board here for the Department of Economics. And so what we want to do is just tell you a little bit about economics, because most people think economics is what you're doing right now, is government stats, compiling stats, working in basically government or the nonprofit sector, but it's a whole lot of stuff. You can do a whole lot of industry. I'll give you a quick background and let Michael give you a background. We have about 15 minutes. Is that right? So I have 2 degrees from Ball State. I have a degree in economics and I have a degree in risk management. When I came out, I had no idea what I wanted to do. I still have no idea what I want to do when I grow up, which is awesome about an econ degree, because you can do anything. So I think what we want to start out maybe is, we did this over here. What are some of the majors we have right now in the class? No majors? Construction management, all right.
You said construction management?
Finance. Accounting. I'm going to pick on you later, for sure. Both my parents are CPAs. Your dad's a CPA too, isn't he?
My dad is a CPA.
Notice we're not CPAs. Anyone else? Undeclared. What do we have in here?
Business administration.
Business administration. All right. Entrepreneurship.
Business analytics.
Analytics. All right. Cool.
Who here knows what they want to do when they grow up?
One guy. There you go. 2, 3. All right. Well, I noticed no one said economist, or no one's got an econ major. But you can do lots of different things. I think it comes down, when we talk about it, is you guys have any idea how much money you want to make, or how much money is it going to take to live when you come out? How many of you guys here want to live in Indiana for the rest of your? Are you planning on staying here? How many are planning on getting the hell out? Quite a few. Some of them very proudly are raising their hand.
Where do you guys want to go? Somewhere where you don't get snow.
Somewhere you don't get snow, all right. So, I mean, I think it's important to, what's the cost of living gonna be? How much are you gonna make getting out of your first job? Like, these are important things you need to be asking yourself at this point in time. And what kind of major is gonna do that? What kind of major is gonna have the flexibility? Because they say the hardest job is your first job to get. I know it certainly was for me. I know when I came out, I made $30,000 was my starting salary. You remember what you made coming out?
I made $35,000.
Oh, man,
I did better than John.
no kidding. Hell yeah. It wasn't that long ago. So, the nice thing about economics, it has a pretty high starting salary. But the interesting thing is we should put this stat on here. We'll have to do it for next year. If you look at the billionaire list, there's a lot of them have majors in econ. Because you can go, one, it's a way of thought. So it just helps you with business. And two, you can go into all kinds of different occupations. Law is a big one that we see. If you look up the folks in the House and Senate, now that you want to model your career off a politician, but a lot of them have undergraduate degrees in economics that get into law. So you'll see this as entrepreneurship. A lot of these folks that run very high-powered organizations have undergrads in economics. I went on and got my MBA, and you see a lot of people continuing on after school. But the important thing is that the median income right there is real high. So that's interesting when I pick on my accountants. Accountants tend to make a little bit more, actually a little bit less, even the same coming out. But you tend to plateau in a lot of these things if you shoehorn yourself into one thing. But with economics, you can get into a lot of different stuff. I guess we never really introduced ourselves. But so when I came out of Ball State, I started to do that. I went to work for a group of power companies and ended up on their trading floor. Went to work for another trading floor. And in my early 20s, I basically had a $3 billion portfolio plapped on my lap. Who thought it was a good idea to give $3 billion to some, kid out of Ball State? But I did it. I managed it. Was very successful in the trading environment. My company got acquired, took a buyout, and kind of became a serial entrepreneur. I've owned a dozen-ish different companies. I still own several companies. I work for a bank out of Atlanta. I do a lot of really large project finance stuff, make rich people richer, basically, and continue on my own companies. So you want to tell a little bit about your background?
Sure. So I graduated from Ball State in 2003. I got a job selling chemicals that had nothing to do with my econ degree. But the great thing about an econ degree is it's a degree in bullshitting. Anybody that reads the newspaper every day, you can make a theory about what will happen next or why you think what will happen next based on your econ degree. It's, it comes down to the basic principle of at a lower price, I will buy more, at a higher price, I will buy less. And you find ways to apply that to life everywhere you go. So I sold chemicals for a few years, and there was a commodity chemical that we sold called epoxy resin. And I found it extremely frustrating to sell epoxy resin because I'd sell for a factory and my price might be $1.50 per pound. And I'd go in and my competitors might be at $1.70 or $1.85 one day. And the next day they'd be down at $1.30. There's no open market exchanges. So after a few years of doing this, I said, I'd go off on the entrepreneurial path, and I opened up an exchange, or attempted to. Wasn't necessarily the best time to open up exchange, but it pushed me into the entrepreneurial mode. And I used the econ degree to get the whole way through. And we kept making relationships. And eventually, after failing at that, I bought a toy company. I don't know how many of you guys, when you were kids, played travel bingo, sitting in the backseat of your parents' car. You'd close a little red window and be like, I saw a horse or a car you bought at a Cracker Barrel as a child that ended up getting thrown out the window. But I bought that company, let's see here, in 2011. And we're still running it today, but we've acquired a half dozen other toy companies along the way. We've made up our own games. Most recently, last October, I bought the assets of what's called Kid Made Modern. So next time you're in Whole Foods, feel free to buy a craft set, and some portion of that will come back to me. Assuming we're not losing money, then you're just paying, my overhead or some portion of it. But we've had a lot of success with it. We've built up a huge Amazon business in the process. And, econ has really actually helped shape the thoughts of, hey, what do you think is going to happen next? I wouldn't pick on somebody who got an accounting degree. I think it's great. There's going to be a shortage of CPAs in the future. There's a shortage of CPAs today. But if you want to do more than be a CPA, I double major in accounting and economics. It's not that much harder. It's not that many extra classes. I was one class short of an accounting degree. I work with my dad every day. I hired him shortly after COVID to become my CPA. But economics has always been the fundamental ability to make a conversation about what do you think is happening in the world? You know, I think if anybody's paying attention, you can't trust the left and you can't trust the right politically about what's going on. You have to be able to start making your own decisions about, hey, mathematically, what makes sense in the world? Where should we be going? With these idiots running the world, what do we think the next step will be and what's going to come? And how do we make money in between? Because you know, you're going to spend 40 years of a career and you're going to spend 40 hours every week doing something outside of your house. And if you want to do it on your own, you're probably going to spend 60 hours a week thinking about it, but it keeps you busy. It ultimately becomes, you start off saying, I want to make enough money to feed a family. And then once you get there, you go, it's a game. I want to keep playing this game. And you want to keep having theories to move forward from there. I can't say enough good things about my economics degree. So I was really glad to come down here and talk to you guys and answer any questions about getting a degree in economics. It wasn't that hard as long as you don't take econometrics like Jonathan did. But it was a ton of fun and it really did create a discipline of how to think about life and what to think about the world.
He brings up a good point that I think that we want to make and really go over is that the great thing about the economics degree is it's very easy to double major. So I noticed no one raised their hand saying that I'm going to major in economics, but please consider it because your first job out of college is by far your hardest job. So what's going to set you apart from someone else if you're competing with a Ball State student or from an IU student or Purdue student, or if you go out of state, you know, their state's student, it's economics. It truly can. And it's really easy to pick up a double major because you're required to take 201, 202, 221. Depending on your major, you may be required to take 301. I believe accounting has 301.
Yeah, I know specifically the finance and accounting majors. It's not like you were saying, it's a very small number of classes to double major. And I always, describe it as it sets you apart from the field. If every other finance major and then you have a double major in econ, it lets them know that you're able to think in a slightly different way than most people. And that way of thinking is very advantageous to most companies. Also, I know that like you guys have already mentioned with the entrepreneurship, great program, great degree, but most of you really successful entrepreneurs are able to think economically.
Yeah.
So a double major in economics for an entrepreneurship major, I think is also, highly beneficial. But that's
sure.
my 2 cents.
Absolutely. And that's why we're here. We want to explain to you because most people just have that mindset that economists are economists, but they're not. They're in all kinds of things. And when you're setting for that first interview, across someone in HR, they likely had Econ 201. They're in an HR major. They're like, holy shit, that was hard. This guy must be really smart. So if you had 201, 202 and liked it, if you're having 221, you could like it or not like it. Let's face it. But there's lots of other things besides the business side and the stats side. In this world, the stats part and the econometrics part are becoming insanely important, more so than 20 years ago when we came out. But it's the thinking, the critical thinking. Please look at picking it up because all you have to do is just work your electives a little bit different. And if you take electives on econ-driven classes, you can pick up a double major fairly easy. And of course, the minor is almost there anyway because you have to have so many core classes that are already in there. So even if you don't consider a major, consider the minor because you can do a lot with it. So I know something that probably Michael wants to hit on as we kind of start getting on time is the importance of internships. I know I had an internship. For me, the most important thing I had in my internship was to be like, hell no, I ain't getting into this field. I had an internship in insurance. So I'm like, yeah, not for me. So there's some really important things with internships. Here, what we try to do as the econ board is to help students find internships. There's a lot of companies looking for interns and another great way to set you apart. So you can probably give a little recruiting pitch yourself.
I mean, if anybody's from the Chicago area, we'd love to find interns. But it's a good part, and internships more importantly are the relationships you make. If you have a good internship and it's your first job, more important than your major, I would say, is your group of friends. Make sure you're looking around at the friends you make, because I'll say the best friends I made in my life were here at Ball State. And they're people that I talked to today, and we were all driven and we all had similar goals of where we wanted to be in life. and they've been an incredible support system. You can learn everything you want here at school, but there's an emotional side to your career and to building a life that is not necessarily easy to talk about and not talked about often. But those friendships and those relationships of somebody that, hey, you've been there, you've done this before. I've trusted you because we got drunk together in college or we were totally irresponsible together. Not that Jonathan was ever irresponsible. He was always a picture of perfect responsibility. But I might have been, and he put up with it. And those relationships are really important. So making that core group of friends that can support you through that is really what you're doing here today. It's as important as your major. And the internship is, yeah, go there, get a career. Whether it's your first job or your second job, mentors are great. Find somebody who you find interesting to talk to, that finds you interesting to talk to spend time with, because they're going to be able to mentor you and say, hey, this is a good decision, this is a bad decision. My job selling chemicals, I worked for this great Iranian guy, and goalie was crazy as could be, but he did everything for me in my career. He was always willing to loan me money if I needed money. He was always willing to give me advice. I would fail, and he would still be there as my friend to tell me, this is how you get going again. And it's hard to find friends like that, especially the older you get. So look around and make sure you're putting energy into those friendships today. It's not a waste of time. Make sure that the friendships that you are putting energy into are with people that you think in 10 years from now are still going to be useful in your life. I think it was one of the best parts of coming to Ball State were the people that I met. So that was a different tangent, but I went off on it anyway.
No, I think he hit on a lot of stuff that is super important, and know that we here as the econ board for our majors are that mentorship, are that sounding board, are a way to get the first job. I got my very first job out of school because alumni that had an econ degree called Dr. Bohannon looking for people, and I ended up there, and now I'm 100 miles from where I thought I was going to be. But because of these connections, so we work really hard as the alumni network. It's a very small fraternity of folks that have econ degrees. We'd love to see more people in it. But because of that, there's this loyalty to make sure that Ball State students land on their feet. So we have a board, on the board, we put it up earlier, but reach out. We have LinkedIn. We didn't have LinkedIn when we were your age. Reach out to people that have Ball State econ degrees and hit them up. We'll all respond back. We'll all take, Michael's a great guy. You can look him up and call him on the phone, and he'll answer his phone and we'll talk to you. So that's what makes this a very unique major. We have professors that are highly invested to make sure you guys succeed. And they have alumni, no alumni. Just ask any of the econ professors. They likely know someone in a field you want to be involved in and can get you at least a phone call or an interview, which is the hardest thing. That's kind of the whole point of coming out of college is, what do you want to do? How much money you want to make? These are all things that most people don't talk to you about, but it's really important to think about. So, and we're here to help you guys. So I think that's it. I know we've taken a little bit more than time, but do you guys have any questions for us? Do you have any questions about the majors that maybe any of us can answer? Career questions? Want to know how tall he is?
Or how small he is? Or the variance.
Could run a regression model on that. Nothing? You guys all know what you want to do? You're all set? Got the answers?
It's an awkward form to ask questions in.
Do you have any questions you think maybe we should go over?
I think remind me, is Dr. Horowitz the internship coordinator now?
It used to be Tung Lu. I don't know who
Okay.
it is now.
He's got a big sign up here right here.
I was gonna say, I think that it switched over, but yeah, if you guys ever,
On 125 at 5:30 p.m. and 1:39.
okay, if
It's
you
right
ever,
here, and the screen goes up in the class. Find out.
if you're interested, in any opportunities, like he kind of has everything kind of put together, and he's gonna have more information than even I would. I'll get this, I have these slides, I can post them up on Canvas too for kind of all the contact information for everybody on the board. And yeah, I think the hardest thing, like even in a setting like this, like I always tell people, like the dialogue days thing, like just show up to things and ask questions, meet people. Like there's some like building relationships with people outside of the university is, you never know what opportunities it's going to create for you, create for your first job opportunity. So if you do have questions, ask them. meet as many people as you can.
Yeah, we appreciate you taking the time.
Anybody here like card games? Yes, so we brought card games in. So you guys want one? We brought some in for the classroom.
You do a drinking game off that?
I have no idea.
Yeah, right.
There you guys can, Jonathan, grab the bot, pass them down. It's our new game. I'm just shamelessly promoting it. The decks cost me nothing to make, but I feel if I get you guys to play it, there's a QR code with instructions. You'll teach other people to play it, and hopefully it catches on.
Michael's one of those local guys that brought a factory here down and helped them through the challenge.
I did. I do it again. Although I'd probably try to avoid China, but it's really difficult to find a better option.
Yeah, that's all. All right. Let's. These are the video.
Well, guys, we appreciate it. Like I said, if you got anything, please feel free to reach out, connect me, LinkedIn, email, whatever it may be. And certainly talk to any of your professors and good luck.
And hustle the professors. They're financially incentivized to make you a major in economics.
Yeah.
So, there might be some negotiating power in grades. I don't know. But they have a financial incentive for you to pick economics. So let's see what you can leverage that for. Thanks again.
Yeah. See you guys.
See you.
Appreciate it.
Thank you. You guys are back here from the rest of us too.
Okay.
Hey. All right. So, I think I'm an econ professor, like they mentioned. So like, I'm always trying to push that major onto people. But it's always great. Like I'm on the advisory board. So I talk with these guys and other alumni a lot, and they are a really valuable resource. I see a lot of them, really hammering home the importance of economics. They're also some of the people I referenced that hammer home the importance of Excel. They kind of already mentioned things are really getting pushed more into this data-driven world. So that's all. I'll kind of leave it there, and then we'll kind of jump into material today. We'll do a little bit. I kind of went through the iClicker. Like I said, if you guys are still having problems with that, shoot me that email with your physical one, and I can manually update everything there. I have also made sure that this in-class work is everything that we've done. So please don't wait to work on that first Excel assignment. Start working on that now. Should have everything that you need after today to kind of complete that. There's a couple things that we'll touch on today, but you can work through 95% of this assignment right now. Okay. So get going here with the slides. So where did we leave off? We were talking about measures of central tendency of data, right? And so we talked about the mean, so it's hopefully a review for a lot of people. We also have two other measures of central tendency, which are the median and the mode. So the mode is the easiest one. It's just what observation or what value occurs the most, right? So if I've got a frequency distribution, how could I very quickly identify what the mode is? Let's say it was discrete data. So I've got all these bars. How could I identify the mode? Remember, how are we coming up with these bars? You usually had to calculate what the frequency of all these different responses were. So if the mode is the response that happens the most frequent, how can I identify that based off of a frequency? Yeah, just the highest bar, right? So that one's pretty easy to identify. Now, if I have continuous data and I have to put it into bins, it's a little bit more difficult, right? But we'll see some easy ways to do it in Excel. The median is going to sound similar to the mean, but it's a little bit different. It's going to be the true middle point of the data in the sense that 50% of the observations are below it and 50% of the observations are above it. Okay, so I can give you an idea about maybe why the mean and the median might be a little bit different. But let's think about a data set like this. Right? If I wanted to calculate the mean here, I need to simply add them up, and then I have 5 numbers, so divide by 5. So if I add these all up, what, 10, 20, 30, divided by 5, I should get a mean of 6. Right? Now, if I wanted the median here, all right, that's going to be the middle value. Now, I wrote these from smallest to largest. That kind of made it a little bit easier. Right? The value that's going to split this, where 50% of the observations are above, 50% are below, is whatever number's in that exact middle position. Right? So this is my median, happens to be the same as my mean in this example, but I've got 50% of my observations above and below it. Right? So in practice, probably the easiest way to do this by hand, although with thousands of observations, we're not going to do this by hand, would be to order your observations smallest to largest, cross off the highest, cross off the lowest, cross off the highest, cross off the next lowest, next highest, all the way until you get down to the very last observation in the middle. Right? Now, if this is an odd number data set, that's easy because there's just one number here. But you can imagine, well, what if I have something like this? Well, I can cross off the highest, lowest, next highest, next lowest. I'm left with these two. If I cross off the next highest, next lowest, I've got nothing, right? So if you have an even number data set, one additional step, which is once I'm left with these middle two values, simply take the mean of those middle two values, and that'll be my mode. Okay. So an even number data set, we have a little bit more work to do, but really not too bad. Okay. Any questions on this before I erase some of this and go back to the original one we had? Okay, so I want to make a point about mean and the median here. Okay, so sometimes I think maybe this is on the flip side. I've got a median example here. I'll jump the gun a little bit. I was about to jump the gun. We'll go through this quick. So median, if I have that point score data that we used last class to calculate means, how would I find the mode here? Well, the mode was just the number that happens the most frequent. The only value here that happens more than once is 35. All right, so the mode, identifying the mode should be pretty easy, especially with these small data sets. If I wanted the median, how can I do that? Well, I'm just going to do this process. I could rewrite these from smallest to largest, or I've got a pretty small data set here. Just start crossing off the highest and the lowest value. So 15 is the lowest, 35 is the highest value. Whoops. So I'll cross those off. Next highest, 35 and 16. Next highest and lowest, looks like it's 18 and 28. And I'm left with that one value in the middle, which should split my data exactly in half, right? So if I go back and think about if 20 is my median, 1, 2, 3 of the observations are below it, and 1, 2, 3 of my observations are above it, right? So it should exactly split my data in half. Okay. Any questions on that before we keep moving here? Shouldn't be too bad. I've got another example here that I would sometimes use for iClicker. Sometimes I won't work through these in class using them for the iClicker, but sometimes what I'll do is like I put the iClicker title on there. So when we get close to the exam and you're reviewing, these are questions to make sure that you know how to answer. Right? So, if I wanted this commute time, right, like I mentioned, sometimes it's easier to write them out from smallest to largest, especially with a small data set. You're then just crossing off the highest, lowest, next highest, next lowest, next highest, next lowest. You're left with that value in the middle. Okay. Shouldn't be bad. Any questions on this though before we keep moving? Now you can imagine, like with a really large data set, it's going to be really difficult to do. But I'll briefly show you today in Excel. It's a built-in function. It takes almost no time. We can get these means, medians, and modes very quickly for very large data sets. Okay. So we had this original data starting out, really simple data set, but they wanted to kind of make the point why sometimes the median is more useful, especially with small data sets, than the mean. Okay. So let's say I have a data set that looks very similar, right? But my very last observation, instead of 10, is 100. Okay. So if I want to find the mean here, I add these up. So I've got what? 10, 20, 120. Divided by 5. Let's see what? No, 20, no, 24, right? Okay. So we've got a pretty high mean compared to the other one, right? This one value really pulled the mean up quite a bit, right? That one value changed the mean from 6 to 24. Okay. What's the median here? So we go cross off the lowest, cross off the highest, next lowest. I'm actually have the exact same median as I did before, right? You might have been thinking there was an even number and looking at it, but right, there's not a number data set, so it should be one of the values that's in our data, right? So notice I had this one value in my data set, this extreme, what we would call an outlier, right? It was a lot higher than the rest of the data. It'll pull my mean up a lot, but it doesn't influence my median near as much because it still counts as one observation, right? With the mean, the actual size of the observation or the value matters. With the median, it's just the number, right? Like I'm crossing off one number. So it doesn't matter if the highest number gets even higher, it's still going to get crossed off one time, right? So sometimes, especially with small data sets, that median will give you a much better idea about where the middle part of the data is, because the majority of observations, 80% of the observations, 4 of the 5 are like under 10, right? So that mean of 24 is really kind of being misleading about where most of the data is in this little small data set, okay? Any questions on that idea? So that's one example of how you might get a really extremely large value to influence your mean, but not your median. If you have it such that, like the first one, the mean is exactly equal to the median. Well, if you look at this data set, right, every value on each side of the mean and the median was like equal distance, or we have what we would call like a symmetric data set, right? If I were to like map this out, it was like have equal number of values on either side of that mean and median that were equal distance away from it. So we end up, when the median is the same as the mean, also ends up being the same as the mode, because that middle part of the data is going to be where the highest bar is. And then it'd be symmetric, right? It would fold on top of itself around that mean and the median. Okay. So anytime you have the mean and the median be the same value, you know you've got a symmetric data set, right? If you have a situation where you've got some extremely large value, what would that look like? Well, if I have some extremely large values, my right tail is going to start to get longer, right? Because I'm now going to have, just like when we're thinking about income in the US, I'm going to have some people making a lot of money, right? And when I add that in and I calculate my mean, that's going to pull my mean way up, right? But it's not going to influence the median quite as much. So when I have this long right tail, I end up with the mean getting pulled way further to the right than the median is, or the mean is greater than or to the right of the median. That's actually why we call it a right skewed distribution. So remember, we talked about that last week. I said, for now, long right tail means right skewed. Really why we call it right skewed is because the mean is being pulled to the right or is greater than the median, right? So long right tail, you're going to have some extremely large values pulling that mean up to be much greater than the median. Okay. The exact opposite is true if we have a long left tail. Well, now we've got some extremely low values. Those are going to pull the median, they're going to pull the mean down, right? And they're going to influence the mean a lot more than the median. So for a left skewed distribution, we have this long left tail, we end up with the mean being to the left of or less than the median, which is why we call it a left skewed distribution. Okay. So the naming of the distribution really comes from this relationship between the mean and the median. Might be a good thing to jot down, right? If that mean is to the right or greater than the median, right skewed distribution. You don't even have to see the rest of the data. I can just report to you what the mean and the median of that variable is. If the mean is ever to the left or less than the median, then we're going to have kind of this left skewed distribution. Okay. Any questions on this? It's making sense a little bit. Okay. So where are we at in time? What do I want to do? 15 minutes. All right. I think before we go into we'll start here and then I'll kind of end on Excel, show you some stuff real quick. Okay. So this one I'll go through very quickly because it's pretty easy, right? You've probably used this before, or at least someone's mentioned this. I think the idea is not new, which is after we know where the middle part of the data is, we want to know how much does the rest of the data vary from that point, right? You can imagine, let's say I have a data set with something like this. starts at 1 and goes all the way up to 100, right? Well, the range of that data set, right, is going to just be the difference between the minimum and the maximum. So here, and kind of think about my range is what? 99. So it's kind of nice. It shows me like, well, you know, gives me a quick idea about the dispersion of this data, right? It ranges everywhere from 1 to 100, right? Where I've got this range of 99. Now, what if I had a data set? Actually, sorry, no, that was the one I just did. What if I had one that looked like this? Where it was all ones, and then the very last observation was 100. Well, what's the range of this data? Well, starts at 1, goes to 100. I still end up with the exact same range. So it's a good starting point, right? Taking that maximize the minimum kind of lets me know like how, you know, what range of values could I possibly see. But it's kind of flawed because I know for sure there's a lot less variation in this data, right? There's 99 ones and then one observation is different. Here, every single value, right, is different. So I want something else to be able to capture that there's more variation in that data set, right? The range isn't going to do that. It's a good place to start. It's not a perfect measure. So what we're going to do is calculate something we call the variance. Okay? So we've got the population and the sample variance, and they're calculated slightly differently. So I'll try to walk you through kind of this notation. I'll explain more of what you're going to do in practice. So just to kind of have some numbers to work with, I'll go back to that small data set that's kind of easy to think about. So actually, let me give myself a little bit more room here. So we have this small data set. What we're going to do to calculate the variance is go through every single observation and figure out how far away is that observation from the middle part of the data. So remember, this summation sign means add up. After you do this for every single observation, add them all up. So what is the thing that we need to do for every observation? We're going to take the value that that observation has for X, subtract the mean, figure out how far away from the middle part of the data it is. And then, so here we have what? 2 minus 6, so -4. We would then square it, right? Now, the reason why we square it is kind of two things, right? The first is, even if I have something that's below the mean, -4 times -4 ends up being +16, right? Notice, even if I have an observation that's above the mean, 10 minus 6 is what? +4. So both of those observations are equally as far away, right? 2 is 4 away from the mean of 6, 10 is 4 away from the mean of 6. So they're both the same amount of evidence of variation in my data set, right? It's just that one is above and one is below that middle part. But we don't care what side it's on, we just care how far away it is. So by squaring it, everything just becomes a positive value. Now when we add them all up, every single observation that's at least a little bit away from that middle part or a little bit away from that mean, we'll add that there's some variation in this data set into our variance calculation. Okay. We also square it because, think about it this way. Let's say I had 2 columns here. So let's say I had a value that was 1 away from the mean. If I didn't square it, and let's say I did something tricky that we haven't really talked about, but I take the absolute value. So all that means is you drop the negative sign. So this way, once again, it won't matter if we're above or below the mean, it would still add to the variance. Well, 1 squared is 1. If I had something that was 2 away from the mean, 2 squared is 4. Something 3 away, squared is not. Notice when I square it, the further away I get from the mean, it kind of blows that value up even more, right? 1 becomes 1, 2 becomes 4, 3 becomes 9, 4 becomes 16, right? So I'm squaring these values. I'm really over penalizing being really far away from the mean, right? Like everything that's away from the mean still adds something to the variance, but by squaring it, I'm really over penalizing values that are really far from the mean because those are observations that there's a lot of variance in that data or a lot of variance in that variable. So that's all that this formula is saying. Go through every observation, subtract the mean, square that value. So here, we already did it for 2, but 4 minus 6 is -2 squared is 4. 6 minus 6, well, that's an observation that provides that, yeah, just from this observation, there's no variation in the data set, right? This is adding no variation or adding nothing to my variance because it's the exact same value as my mean. And then we get the last one, right? 8 minus 6 is 2 squared, 4. I would then add all these up, right? So this is what, 20 plus 0 plus 20. So I get, when I add those all up, I get 40. I have one more step to calculate my variance, which is then, okay, each one of these observations provided some evidence of how much variation from the middle part of the data that there was in this data set. But let's say I have like all this variation across 5, but what's like the average variation from that middle part? I would then divide by the total number of observations that I have. Okay. So you can kind of think about the variance is like, in a weird way, it's like a mean in the sense it's like giving you the mean or the average variation in the data or the average deviation from that mean across every observation in your data set. Okay. Now, some of the observations provides you evidence that there's no variation. Some provides you evidence that there's a lot more, but the variance is picking up kind of the average variation across every single observation in the data. Okay. Any questions on this before we keep moving here? Okay. Hopefully it's making some sense a little bit, or at least a little bit. We'll kind of hammer this a lot more next class. When we want to calculate the sample variance, so for right now, I'm not going to give you a perfect explanation as to why this is. It's kind of no, and then as we get into further topics, maybe this will make a little bit more sense, but I can kind of give you a rough explanation as to why we have to do something different for the sample data initially. So population variance, last class we introduced a notation, which was that sigma squared using the Greek lettering. Sample variance, we just go to S squared, right, using kind of our English lettering system. It's the exact same process. We're still going to go through every observation, find out how far away it is from the mean. It's just now we won't be able to calculate the population mean because if we only have sample data, all we can do is calculate the sample mean. Now we'll calculate it the exact same way. We just use slightly different notation, right? So once I find how far away that observation is from the mean, I square it. Do that for every single observation, add them all up. The only difference when I'm calculating the sample variance is instead of dividing by my total number of observations, I'll divide by my total number of observations minus 1. Okay. So what is this going to do? If I divide by, let's say, I divide something by 2 or 1, right? So let's, I don't know, we could even do, let's take that 40. Let's say it came from 2 observations. 40 divided by 2 is 20. 40 divided by 1 is 40. All right. So by dividing by a smaller number, what have I done to that sample variance? If I divide by a smaller number, that should make my fraction larger, right? So by dividing by n minus 1 here, I kind of am erring on the side of caution, and it's erring on the side of caution. There we go. And it's kind of causing that sample variance to be a little bit higher than if I had just divided by the total number of observations. And the reason we do this is once we get to things like hypothesis testing and confidence intervals, we know that our sample data, we want to, we'll be making like rejection decisions, and by inflating that sample variance a little bit, we're always going to be erring on the side of caution. Like we're always going to be not rejecting as often because we know that we just have sample data. There could be more variation in this data, or we could have, some of the observations from the population that provided evidence of a little bit smaller variation, right? And so by having a larger variance, it'll kind of help us out once we get to further topics. But for right now, if all you want to do is memorize that for the sample, all you do is one additional step, which is instead of dividing by n, you'll divide by n minus 1, right? And kind of overinflates that variance because you've only got it, you calculate it from sample data. The other thing I wanted to mention here was, this doesn't really play a huge role, but the variance is going to be whatever the variance of the variable you were using. So if it's income, your variance would be in dollars. If it's height, it would be in inches, so on and so forth, right? The units are exactly the same as what we're doing with like the mean or calculating any other statistic. Okay. So that's kind of our first look at the variance and these measures of dispersion. We'll go a lot more in depth next class. We'll calculate some variances. I'll have you work on calculating a few. But I'm going to open this Excel document to kind of show you one more thing that you should need. Let's say we'll go to this continuous tuition data. I'm going to scroll up here to the very top, and we're going to see how we do things like mean, median, mode, and even the variance, and then the sample population variance in Excel. Okay. So the first thing, we've got mean, median, mode, right? These are all very quick, especially if we're getting used to these shortcuts. So a little bit confusing for the mean is that Excel in their infinite wisdom used kind of our everyday language, which is the average, right? But the built-in function of average is going to calculate the average or the mean for us. Now, what is it going to calculate the average or mean of? Well, all the numbers we select. So if I wanted the average net price of tuition, I select on that first cell. I hold Control Shift or Command Shift on a Mac, hit the down arrow, it selects the entire variable. Once again, I guess I could do this by hand, but can you imagine adding up all these values and then divided by the total number? Like this would take forever, right? So now if I want to get out of this cell, I said another nice shortcut is instead of scrolling back up, if I just hit enter, closes that parenthesis for me, and it finds kind of this average or this mean net price of tuition, right? So it's about what? $20,000, right? Across all these universities. Okay. Any questions? That shouldn't be too bad. So equals average. Now the other ones are easier because they're literally just the name of the statistic you want. Equal sign median will find you the median, right? Once again, if I had to figure out what the highest and lowest value was from this data set, cross it off, next highest, next lowest, it'd take me forever. But if I just use this built-in median function, Control Shift, Command Shift on a Mac, hit the down arrow, selects the entire column of data, hit enter to close that parenthesis, send me back up to the top. It'll calculate that median for me very quickly. Now notice this is probably a pretty symmetrical data set because that mean and median are very close to each other, right? Not very far, far apart. And then if I wanted the mode, I'm guessing this might have an issue. So if I've got a truly continuous variable, and this one is not truly continuous, but if I'm calculating the mode, what could be a problem if I've got a lot of variation in my data? And let's think about maybe even a smaller data set. So let's say I have a data set like this. What's the mode? Everything only happens once, right? So sometimes, depending on your data, the mode might not make as much sense. My guess is we might get an error here. I don't know for sure. But right, unless we've got two universities with the exact same net price of tuition, right? Which it could be possible. I've got 3,500, so it might be. If I don't, it's going to give me an error term, right? It's going to say everything only happens once. There is no true mode for this data. So we'll select it, see if that's the case. It looks like there was a net price that happened the most frequent here, right? But you can imagine how it's very possible that that might not be the case and you would get an error message there. Now, the data I gave you for your Excel homework, you shouldn't get an error. So if you can calculate them, you should be able to calculate the mode there. But I just want to kind of mention that that is a possibility. Any other questions on that? Yeah.
Top one you did, the mean.
Yep. So the mean is the only one that doesn't have a good name, right? I mean, in the sense is it doesn't have, you don't use a built-in function mean, it's the average function. The other two are kind of the same name. Yeah, one more thing I want to show you before you pack up. So we'll kind of revisit this next class as well. So let's say I wanted say I have, every university here. So this is population data. Let's treat it that way first. We also have this built-in function in Excel to very quickly find us the variance. Like I said, we'll do a little bit more of calculating the variance by hand next class, but you can imagine, like going through every observation, subtracting the mean, squaring it, that could be pretty cumbersome if we had 3,000 observations. So this built-in function does all of that work behind the scenes for us, right? So if I use var.p, that finds me the population variance, right? I then just select the variable I want to find the variance of, hit enter, and it does it very quickly, right? Now, what if I wanted to find the sample variance? It's going to be the exact same thing. So instead, assume we had sample data. The way we would find our sample variance is just var.s, right? So nothing too tricky there. var.p gives you your population variance, var.s. If you're using a Mac, there are other, let me see. There are other variants. So like var a and just the var, notice these are old functions. Try not to use those because it's not very clear unless you're doing some really good Google searching, which if this is giving you this sample or the population. This var.p and var.s are the most up-to-date functions that'll give you that population or that sample variance. Okay. All right. So you're having issues with iClickers, like I said, reach out. Otherwise, we'll start using those Wednesday. I think I'll be able to get everyone kind of matched up. Start those homeworks, and I will see you guys on Wednesday.